If you're a music lover or frequently use headphones, it can be really frustrating when an ear cup breaks. Instead of rushing out to buy a new pair, you can actually repair at home using some simple materials and a bit of ingenuity. In this guide, I'll show you how to use glue, plastic materials, or even small accessories to reconstruct the ear cup, restore your headphones to normal use while still keeping them comfortable to wear. This is a cost-effective and quick solution, and also a fun experience for anyone who enjoys reviving their personal gadgets with their own hands. I'll wrap this fabric section with a thin layer of plastic bag. This will temporarily protect the fabric surface, preventing dust or small particles from sticking before I proceed with repairing and finishing the ear cup. The plastic layer keeps the fabric clean while also creating a smooth surface, making the next steps of the repair process much easier. Before starting to repair the broken ear cup, I'll prepare all the necessary materials. First, I'll start with the baking soda tape. Thorough preparation will make the repair process faster and more efficient. Here, I have quite a few old batteries. I need to remove the battery casing to extract the carbon rod inside. I'll carefully take out the carbon core, which will be used for various DIY projects, from simple electrodes to small experiments. While handling the carbon rod, I'll make sure not to break or damage it, and I'll also take precautions to stay safe, avoiding direct contact with any remaining chemicals inside the battery casing. After extracting the carbon rod, I'll lightly sand its surface with sandpaper. This process creates fine carbon powder that can be used in the next steps of the project. While sanding, I'll work slowly to prevent the rod from crumbling too much, and I'll collect the carbon powder on a sheet of paper or in a small tray for easy use. After sanding and collecting the carbon powder, I'll combine it with a little baking soda. Mixing these two ingredients creates a fine, workable mixture that can be used to fill or reinforce small broken or cracked areas on the ear cup. I'll mix the carbon powder and baking soda thoroughly until the mixture is smooth and lump-free, preparing for the next step, applying to the part of the headphone that needs repair. The black powder from the carbon rod not only helps reinforce the damaged areas, but also provides a color-matching benefit. When mixed with baking soda and applied to the broken part of the ear cup, the carbon powder helps the repair blend in with the original black plastic. Next, I'll prepare by taking apart a few old staples to make use of the metal inside. These metal pieces will serve as small reinforcement frames, helping to solder and secure the broken plastic on the ear cup. When soldered, the metal fragments create a strong connection between the two plastic ends, reducing the risk of loosening or breaking again later. Now that all the materials are ready, I can move on to the actual repair of the headphones. First, I'll use super glue to temporarily hold the broken plastic parts of the headphones in place. This helps keep the pieces aligned before moving on to soldering or further reinforcement. While gluing, I'll make sure the plastic pieces fit closely together with no large gaps and allow the glue to dry completely, so the ear cup is stable and ready for the next steps. Once the plastic is secured with glue, I'll prepare the soldering iron. To solder the plastic more effectively, I'll round off the tip of the soldering iron, creating a larger contact area with the surface of the plastic. When the soldering tip is hot enough, I'll place each staple segment in the correct position along the previously fixed plastic joints. Then I'll slowly start soldering so the plastic melts and tightly embraces the staple, forming a sturdy reinforcing frame. I'll solder one spot at a time, making sure the staples sink just deep enough into the plastic without deforming the structure of the headphones. By placing multiple staples at different points along the crack, the broken plastic will be well reinforced, reducing the chance of cracking again during use. Throughout the process, it's important to work slowly, maintain a stable temperature, and always prioritize safety, avoiding direct contact with a hot soldering tip or heated metal. After finishing the soldering, you can see that the plastic around the crack is melted and tightly wrapped around the staple pieces inside. The joints have become more solid and are no longer loose like before. When applying slight pressure, the ear cup now feels much sturdier and more stable, giving a firm and reliable feel in the hand. From the outside, the soldered spots are still a bit rough, but the overall structure has been restored and is strong enough for further processing and finishing in the next steps. This soldering process has helped regain the durability of the plastic part, reducing the risk of it breaking again during use. Next, I'll move on to finishing the surface of the newly soldered plastic. Now I'll check the hardness of the mixture made from baking soda and carbon powder after combining it with super glue. Next, I'll place the head of the nail onto a small wooden stick to keep it steady, making it easier to work with. Then I'll sprinkle the powder mixture around the area that needs reinforcement, making sure it covers evenly and adheres to the surface. I'll slowly drip super glue onto the powder, one drop at a time. When the glue contacts the mixture, it will quickly soak in and react, forming a solid, durable layer around the area that needs strengthening. After the glue and powder mixture have completely dried, you can clearly feel how rigid the reinforced layer has become. When you touch it, the surface feels solid and firm, almost impossible to squeeze or to form with normal hand pressure. Next, I'll sprinkle the powder mixture onto the recessed areas along the headphone joint. These spots are usually where the plastic is missing or still uneven after soldering, so adding more powder will help fill the gaps and create a more even surface. After sprinkling the powder onto the recessed areas, I'll continue by dripping super glue over the coated layer. I'll apply it slowly so the glue can soak evenly inside, helping the powder bond into a solid mass. As the glue spreads, it locks the powder firmly to the plastic surface, forming a reinforced layer that blends seamlessly with the previous joint. Just sprinkle a thin layer of powder over the recessed area. Then add a few drops of super glue to secure it. Once the glue dries, the powder turns into a solid layer that completely fills the dent and makes the surface more seamless. This method is especially useful for small details, where plastic welding or using larger reinforcing materials will be difficult to handle and could easily affect the appearance. After the glue and powder mixture has completely dried, I'll begin by using a file to work on the surface. I'll gently file along the joint, focusing on areas that are still rough or raised compared to the surrounding plastic. Filing helps quickly shape the overall structure, bringing the surface closer to the desired flatness before moving on to finer sanding. I'll work slowly to avoid removing too much material, ensuring the surface becomes smoother while still maintaining the strength of the reinforced section. After shaping with the file, I'll move on to fine sanding to finish the surface. I'll use a finer sandpaper and gently sand around the repaired area until the surface becomes smooth and blends seamlessly with the surrounding plastic. Thanks to this step, the rough lines, sharp edges, and coarse marks left from filing will be almost completely eliminated. After the fine sanding process, the surface becomes much smoother and more refined. The previously uneven areas are now leveled out, and the repaired section blends naturally with the original plastic. The rough scratches and sharp edges are gone, leaving a flatter, cleaner finish. When touched, the surface feels even and consistent, showing that the reinforcement has not only restored the strength, but also improved the overall appearance of the repaired part. Next, I'll use a cotton swab to apply black paint over the repaired area. I'll gently dab the swab into the paint, then spread it evenly across the plastic surface, making sure not to apply it too thickly, so the finish remains smooth. I'll work in thin layers, allowing the first coat to dry before adding more if needed. This helps the color blend better and adhere more firmly. Once finished, the repaired section blends almost seamlessly with the original black plastic, making the headphones look neat and much more refined. The surface looks clean, uniform, and well blended with the original plastic. The repaired area no longer shows obvious marks of sanding or filling, and the color coating creates a smooth, consistent finish. When viewed from a short distance, it's difficult to tell that this part was damaged before, as the texture and color match closely with the rest of the headphone. Overall, the surface feels solid, visually neat, and aesthetically pleasing, giving the repaired section a near-original appearance. With a bit of patience and careful workmanship, the broken headphone has been successfully restored to a solid and usable condition. Not only is it structurally reinforced, but the appearance is also neat, with the repaired section blending well with the original design. This process shows that with simple materials and the right approach, damaged items do not always need to be thrown away. Instead, they can be revived and continue to serve effectively, bringing both practical value and a satisfying DIY experience.